we have to discuss different types of chemical reactions. There are 5 different types of chemical reactions: combination reactions, decomposition reactions, displacement reactions, double displacement reactions, and redox reaction. The last one, redox reaction. Out of these 5, the first 3 we have already discussed. Combination, decomposition and displacement reactions were already completed in March. So now we move on to the fourth type of reaction. That is double displacement. One of the most important types of reaction, double displacement reaction. Double displacement reaction. Okay. So before we move on to what are double displacement reactions, let us take an example. This example is already familiar to you. In 9th standard you have learned this reaction. So take a solution of barium chloride, a colorless solution of barium chloride. Now you might be remembering this reaction which you have learned in detail in 9th standard. So we take a colorless solution of barium chloride. Another solution, sodium sulfate. Again, colorless solution of sodium sulfate. These two are mixed. A colorless solution of barium chloride is mixed with a colorless solution of sodium sulfate. When we get barium sulfate, this is a solid substance which remain insoluble in the solution. So we call it as precipitate. Such substances are known as precipitates, and the color of this precipitate here is white. So you get a white precipitate of barium sulfate. Along with that, one more product you are getting, that is sodium chloride. Okay, so a colorless solution of barium chloride is mixed with a colorless solution of sodium sulfate. When you get a white precipitate of barium sulfate and sodium chloride solution. Now let us look at this reaction closely. So what is happening here? You just look. Chloride of barium chloride is moving to this side, or we can show it like this. Chloride and sulfate are exchanged, isn't it? Sulfate is coming this side. Look at the product side. Sulfate has come to this side, barium sulfate. So sulfate comes here, chloride goes to the other side. So there is actually an exchange of ions or radicals between the reactants. Chloride is an ion, sulfate is a radical. So there is an exchange of ions or radicals between the reactants, and you get a new product. We get new products. Such reactions are known as double displacement reactions. Reactions in which there is an exchange of ions or radicals between the reactants is known as double displacement reaction. So this is the most common and the most familiar example of double displacement reaction. This reaction we have learned in 9th standard. So we mix a colorless solution of barium chloride with another colorless solution of sodium sulfate, where you get a white precipitate of barium sulfate and sodium chloride solution. So this is the first example. Similarly, we can see the second example. Here we mix a colorless solution of silver nitrate with a colorless solution of sodium chloride. Colorless solution of silver nitrate is mixed with a colorless solution of sodium chloride, and here also there is exchange. Nitrate radical and chloride ion are exchanged between the reactants. These two are the reactants here. So there is an exchange of ions or radicals between the reactants. So what happens here? What are the products obtained? Chloride will come this side, nitrate goes to the other side. So you will get NaNO3, sodium nitrate. Here also what you get is a precipitate, solid insoluble substance, that is called a precipitate, and its color is white. So you get a white precipitate of silver chloride and sodium nitrate solution is obtained. Now the third example. Okay. Another colorless solution we take, that is lead nitrate, plus it is treated with potassium iodide. Lead nitrate is treated with potassium iodide, colorless solution of potassium iodide. Here also there is exchange. Nitrate is exchanged with iodide. Nitrate and iodide are exchanged between each other, and you get nitrate, the iodide will come this side, so you get PbI2 plus KNO3. Here the color of the precipitate is yellow. you get an yellow precipitate of lead iodide. The first two examples, the color of the precipitate was white, and in the last example it is yellow. Okay, and what is common in all these examples, all the three examples? There is formation of precipitate. We can see formation of precipitate in all the three reactions. Okay, so such reactions we call as, such reactions are known as precipitation reaction. Reactions in which formation of a precipitate take place are known as precipitation reactions. So all the three are examples of precipitation reaction. First one, barium chloride and sodium sulfate giving barium sulfate, white precipitate of barium sulfate and sodium chloride. Second one, reaction between silver nitrate and sodium chloride to form white precipitate of silver chloride and sodium nitrate. Then the last one, lead nitrate and potassium iodide, two colorless solutions when mixed, they interchange their radicals, exchange their ions and radicals, and we get yellow precipitate of lead iodide and potassium nitrate solution. So all these reactions there is formation of precipitate. So any reaction which give result in the formation of a precipitate are known as precipitation reactions. And formation of the precipitate we can represent with the downward arrow. This arrow indicate formation of a precipitate. So in a reaction, if you see this downward arrow, it indicates formation of precipitate. Downward arrow always represent precipitate. And if in some reaction you have seen an upward arrow, that indicate the presence of a gas, evolution of a gas. The product formed is a gas. So if you see this downward arrow, it indicates the formation of precipitate. Okay. So one more name is there for this type of reaction, that is double. These reactions are also known as double decomposition reaction. So double displacement reactions are also known as precipitation reaction or double decomposition reaction. Okay, so that much about double displacement. I hope it is clear to you. So what are double displacement reactions? Reactions in which there is an exchange of ions or radicals between the reactants is known as double displacement reactions, and we have seen three examples for double displacement reaction. First one is the most important one, reaction between barium chloride and sodium sulfate. Both are colorless solutions and we get a white precipitate when they are mixed together. That is our observation. The question, children, these type of reactions, the questions comes like, what happens when a solution of sodium chloride, sodium sulfate and barium chloride are mixed? Then what you have to write is, these two are colorless solutions, and at the end of the reaction we can see a white precipitate. That is the observation of this reaction. Okay, so that much about double displacement reaction. And now we move on to the fifth type of reaction, that is oxidation reduction reaction. Oxidation reduction reaction. This reaction is simply known as redox reaction. Oxidation reduction reaction or redox reaction. Okay. Now before we move on to oxidation reduction, let us see what is oxidation. What is oxidation reaction? As the name suggests, there is involvement of oxygen in this reaction. Oxidation is any reaction in which a substance is gaining oxygen. So oxidation is gain of oxidation is gain of oxygen. So let us see some examples, that familiar examples that you have already learned. Reaction between magnesium and oxygen. What do you get as a result of this reaction? You get magnesium oxide. So magnesium is gaining oxygen. In this reaction, magnesium is gaining oxygen. So this is an oxidation reaction. Another one, carbon, when it burns in oxygen, oxygen is added to carbon, isn't it? This is changes to carbon dioxide. So reaction between carbon and oxygen to give carbon dioxide. Another example given in our textbook is copper. When it is heated in oxygen, this triangle sign stands for heating. Copper, what's the color of copper? Copper is a brown colored metal. When it is heated in oxygen, it changes to black colored copper oxide. It changes to black colored copper oxides. All these are oxidation reaction. You can see that the substance is gaining oxygen. Here magnesium gains oxygen, changes to magnesium oxide. Carbon gains oxygen, changes to carbon dioxide. Copper, it gains oxygen and it changes to copper oxide. Now let us see what is. So that is oxidation, gain or addition of oxygen to a substance. Now we see the second type, that is reduction. So this is just the opposite of oxidation reaction. So what will be a reduction reaction? It is loss of oxygen. A substance losing oxygen, that is known as reduction. But a reaction in which a substance loses oxygen, that is known as reduction. So reduction is a reaction in which there is loss of oxygen or removal of oxygen from a substance. For example, this is also, we have seen this example in presence of electric current. This is known as electrolytic decomposition. We have seen this example, electrolysis of water. What happens here? Oxygen is removed from water. Oxygen is removed and it splits into hydrogen and oxygen. Water is losing oxygen to form hydrogen and oxygen. So this reaction is an example of reduction. So before we discuss what is redox reaction, you should be familiar with what is oxidation and what is reduction. Oxidation is gain of oxygen, where a substance gets oxygen or it adds oxygen to it, like magnesium changing to magnesium oxide, carbon to carbon dioxide, copper to copper oxide. Whereas reduction is loss of oxygen. A substance is losing oxygen. Water splits to hydrogen and oxygen in presence of electric current. That is reduction reaction. Now let us see what is redox reaction. Now we will see what is redox reaction. Before that, let me write an example here. CuO plus copper oxide. We have seen formation of copper oxide under oxidation. This is a black colored substance. It is heated with hydrogen. When we see that, it changes to brown colored copper plus H2O. Okay. So copper oxide is heated with hydrogen. When it changes to brown colored copper and water. Now look at this reaction. You look at each reactant. Copper oxide. Look at copper oxide at the product side. What happened to copper oxide? As the reaction proceeds, you can see that this copper oxide is losing its oxygen. Oxygen of copper oxide is lost. It is losing its oxygen. So what is this type of reaction? This is reduction. What happened to hydrogen? See, hydrogen is H2 here, and when you come to the product, it has gained an oxygen. Hydrogen is gaining oxygen. So what type of reaction is that? That is oxidation. Okay, so here we can see that one of the reactant is undergoing reduction and the other reactant is undergoing oxidation. Oxidation and reduction are taking place simultaneously. Such reactions are known as redox reactions. One of the reactant is undergoing oxidation and the other reactant is undergoing reduction. Such reactions are known as oxidation reduction reaction or redox reaction. Now let us see. Now there are two more important terms that you have to learn under redox reaction. One is, look at copper oxide. What happened to copper oxide? It lost its oxygen, or it has undergone reduction. The substance that is undergoing reduction, the substance which undergoes reduction, we call it as oxidizing agent. The substance that undergoes reduction is known as oxidizing agent. It can be represented as OA Now the substance that is undergoing oxidation is known as reducing agent, RA. Okay, now look at this reaction. Which is the substance that is undergoing reduction here? Copper oxide. So copper oxide here is the oxidizing agent. In this reaction, copper oxide is the oxidizing agent, or it is undergoing reduction. Copper oxide undergoes reduction, so it is the oxidizing agent. Now the substance that is undergoing oxidation is H2. This is the reducing agent. We call it as the reducing agent. So this is the question that usually comes from this topic. A reaction will be given to you, an equation will be given to you, and you will be asked to identify the oxidizing agent and the reducing agent. Okay, so the first you have to mark the oxidation. Gaining of oxygen is oxidation, mark it first, then mark the reduction reaction. Loss of oxygen, you mark it. Then the substance undergoing oxidation is the reducing agent, and the substance which is undergoing oxidation is the reducing agent, and the one which is undergoing reduction is the oxidizing agent. Now consider this reaction. You have to find out the oxidizing agent and the reducing agent in this reaction. Before you find out the oxidizing agent and the reducing agent, first thing is identifying which is oxidation. One substance is undergoing oxidation and the other one is undergoing reduction. Those two reactions, oxidation and reduction, first you have to mark. So take zinc oxide. What happened to zinc oxide here? Look at zinc oxide. It is losing its oxygen. Coming to the product side, there is no oxygen with zinc. So it has lost its oxygen. So this is reduction. Now coming to copper. Not copper, sorry. Carbon. What happened to carbon? It has gained oxygen. Carbon gains oxygen. So this is oxidation. So there are two reactions taking place simultaneously here. One is oxidation of carbon to carbon monoxide, reduction of zinc oxide to zinc. Oxidation and reduction are taking place simultaneously. So one is an oxidizing agent and the other one is reducing agent. Find out the oxidizing agent and reducing agent. So what is oxidizing agent? The substance which is undergoing reduction is the oxidizing agent. So what is undergoing reduction here? Zinc oxide. Zinc oxide undergoes reduction, so it is the oxidizing agent. Or another way we can see that this zinc oxide is giving its oxygen to carbon, isn't it? Oxygen of zinc oxide is given to carbon, or it is assisting in oxidation. So it is known as oxidizing agent. It is the oxidizing agent. Now the substance that is undergoing oxidation, carbon, is the reducing agent. Okay, the substance that undergoes oxidation, carbon, is the reducing agent. So this is how you identify the oxidizing and reducing agent in a redox reaction. So this is an important type of reaction. Identifying two reactions will be there, oxidation and reduction. First find out oxidation and reduction. The substance undergoing oxidation is the reducing agent. The substance that undergoes reduction is the oxidizing agent. Okay. So with that, this part of the chapter is over.